Identify each reactant as nucleophilic or electrophilic. And then part two of the question is asking us to consider only the electron density where the above reaction occurs. And then my tips for this question, fairly simple. Look at the charges. The nucleophilic sites tend to be negative and attracted to foreign bonds. And then electrophiles are typically positively charged and tend to form bonds with nucleophiles to achieve balance. So again, in some instances, you can see such as this hydronium here, kind of the positive sign on it. So the other rules is use the bonding rule. So in this case of BR, you can picture it already kind of have, of course, um, 3 lone pairs along with the 1 bond, because again, BR falls in category 7A, and those in group 7 alpha tend to only like to form 1 bond. So that's kind of a dead giveaway right there. And then kind of the other rule here that I have is with carbons, specifically with ones that have double and triple bonds, they tend to be more electron rich. So a picture, because of like those loosely held bonds that are held like right here, they tend to be more electron rich. So picture the electrons out floating, and they're going to tend to be nucleophilic when you see them in this type of form. So let's solve the question itself. We're going to look at the first reaction. So we've already highlighted Br, and we said for the most part that that's going to be an electrophilic reaction. So I'm going to write E for that. And then when it comes to the NH2 that we have here, negative charge, lone pairs, that's going to want to kind of force that bond to balance itself out. So right here, we can write N. And then so for part two of this question, and kind of ties into the last tip that I have, is for a reaction to occur, you need both a nucleophilic and electrophilic site. So because in this instance that we have an electrophilic site and a nucleophilic site, we can say, yes, this reaction can occur. Now, let's look at ones where they won't occur. So we've already kind of went over the rules of this bromine attached onto the carbons, having all the bonds it need, pretty much balanced on. And if anything, it wants something to probably like latch onto it, with it being electrophilic. So we can just write E right here. And then with the hydronium, again, it's positively charged. It doesn't want to form bonds, or it doesn't want to like lose this and become more positively charged. So as mentioned before, it'll be electrophilic. So they want really something to kind of maybe nucleophilic to kind of bond with it so that it can balance itself out. So in this case, because we have 2 electrophilic sites, the answer is going to be no. And then we'll go to this example right here. We've already mentioned the example with the carbons. So loosely held bonds, we're going to go ahead and label that nucleophilic. And then also with NH2, again, wanting to kind of form bonds and forge it, is going to be nucleophilic as well. And then because they're both nucleophilic, it's the same rules apply. Can these reactions occur? And the answer is no. So again, fairly simple. Just assess what you're looking at, refresh yourself on your electrophilic and nucleophilic sites, and you'll be pretty much good to go for this question. But if this video helped you or your classmates, feel free to like, share, and subscribe to the channel. Thank you.